Yeah, we're all serious. Okay. Look, I think the stream's going. The stream is going.
All right.
Hashtag technology. Okay.
Hashtag delay.
So we were making the code topics. Oh well, I mean, do you want to say how you want this to go, Ben, and then I'll say how I want it to go, and then we'll figure out what's going to happen. And Troy, if you got anything to add, then we can work that in too.
I'm a meat popsicle. I don't really have anything to add. I'm just here to listen.
Meatballs got that. Yeah. Okay.
Uh,
So what's your
so,
thoughts?
so I didn't have as much time to go through code as I thought because I spent a bunch of time setting my environment up this week.
Yeah, no worries.
So I'm just kind of still going through the docs and all the code and stuff that has
Okay.
been showed to me in the last couple of weeks. I
Okay.
don't,
Well,
I don't know exactly where is the best place for me to put my time right now.
okay. I got a great suggestion for that. Um, so have you got the latest pull? That's like about 2 minutes old.
Oh, let me do that.
Sorry, that was a bit of a rush. I thought, this is better make the most of the time. So, what I've been working on is, as I explained prior, W15 models is all the building blocks of the chain, all the static models.
Yeah.
What I've been working on this week is rebuilding that entire set of models. I think there's like,
Yeah.
I don't know, like fucking 25, 30 models, something like that. With this new concept that I got, which is that everything's backed by an array. And it's a special array in that it's a compacting Merkle tree.
Right. And
So
by compacting, do you mean what you've explained before, where like it ejects stuff based
the
on?
point of it was that if the array gets very large and you've spent all this time calculating, say the Merkle tree was like, I don't know, 20 levels deep, and then you change one element like at the start, if you were to say shift the array, then you would then have to recalculate the entire Merkle tree.
Mhm.
And so by compacting, I mean that when you say you want to delete something, it defers it till the end, and it pulls off the tail to fill in the holes in the array, which means that the Merkle tree calculation remains as stable as possible, allowing the quickest possible computation time reusing the previous Merkle tree.
Mhm.
Which is also stored as an immutable JS list of lists. Therefore, like the update time is trivial to change the tree. And now you've got these two trees in memory that are taking up minimal space due to their structural sharing, but they still are there to be interrogated independently.
Okay.
And then I was like, that solved a very specific problem. That solved the problem of the network model when the number of chains goes above about 7,000. The sheer weight of doing an object spread on the channels object just bogs the entire system down, and it starts to perform like O factorial or something stupid like that. But with that array being used to store the channel information, it goes back down to time that's dependent on the change to the channels as opposed to the number of channels, which is a great characteristic to have. Not being content with that, I said, well, actually, I've wanted to redo the model system for some time. I think that you and I should go over that model system and how I'm planning to rewrite it, because the model system, if you hate the model system, you will hate the entire system. And so making a model system that we both think is a reasonable sort of a set of tools, first of all, helps, I think, understand rapidly, and also means that long term, like, this is the time that the model system's changing. It's awkward to change it again. Probably it'll stick around, so let's get it to be something that you're happy with.
Okay, so if you give me a sec here, I'm just putting my SSH key up on my account. Yeah, that sounds like a good use for right now, and something I can work on over the next week or so.
Okay. So the key, there's two key primitives going on here. Number one is that Merkle array, which has good characteristics in terms of speed of update, but it also tracks diffs. So basically the model system was based on saying that we can leverage this notion that we have a set of data at block time, and then we manipulate that data during the block making process, and then we want to do something fairly decisive at the end. Mm-hmm. And we are happy to discard all of the intermediate states in between from block to block. And so the model system harnesses that so that you can, it basically, the model system can be told that it's block time, and then from that point on, it just tracks everything that got altered, so that I concluded that I don't want to store full blocks in the database anymore after the database got to several gigs, and I was like, that's not cool. So I want to be able to store diffs, right? But I don't want to have to suffer the performance hit of calculating a diff every time. And so again, the model system tracking its diffs and being able to generate JSON patch style diffing means that the size you write to the database is basically just the difference plus some overheads here and there. And the computation time to get that diff is basically zero, because you've tracked the diffs the whole way, so it doesn't burden you with discovering it. That was all part of the drive to sort of leverage our particular position more, as opposed to trying to solve a general problem of I want general objects, general lists, and general diff solving. I'm like, we have a unique niche use for it. We can actually leverage that to get some gains with a Z. Mm-hmm. The trick that I added was to redo all of the models as objects that actually map back to this array. So when you're working with these models in the system, they look and feel like regular JavaScript objects, but under the scenes, they're actually this Merkle array. And what that means is that when you go to do diff, you lose all the property keys. So it's just a straight array of only the values and only the values that changed. Now, sure, adding compression would have meant that if I was storing it as JSON, the compression would probably get rid of all that. But the point is that the arrays are way faster than objects. And I've got this, this Merkle primitive that is used to make hashing very quick and does all the diffing and diff tracking. And so now, like, the objects also use that same primitive to do their diffing and their hashing, and they report their diffs as simply changes to that backing array. And so,
is it the array you're dropping all the keys and leaving holes, like everything is in the same order all the time?
Well, yeah, because the thing I'm leveraging there is the fact that the entire system was defined as one big JSON schema. Now, I defined it obviously in modules, but you can tie the whole tree together and actually construct a single large schema. And because of that, leveraging that all the keys are declared, there are no additional properties allowed. It is therefore possible at the import time of the classes to go through that schema and auto-generate the majority of the models, which I've done here. And what you get from that is that the keys as described in the JSON schema, I simply take them, sort them, map their indexes back to each other, and then for that class, every time you update that property, it just goes to that index in the array. And so the performance seems pretty good. I mean, it's 0.2 of a millisecond to update a property. It's not terribly bad, given that it's done with something that's immutably backed and is diff tracking at the same time. Hashing's nice and fast. There's no need to use like node object hash or browser hash or things like that, which have that very painful JSON stringify plus stable sort. So they always have to take the object state, it's like the general case is painful, but here is a way to turn it into a very special case, and then like the hashing becomes very fluid because
so the only thing that jumps to mind is, does doing it this way prevent you from changing the models in the future to have more keys?
Well, that depends. So right now, if you change the schema, that's all you have to do to have added a new property to the system and start using it in the classes throughout the model system. So that makes it easy.
But what about upgrading live applications, I guess is what I'm asking about.
Well, I don't understand, sorry.
So like what if you add properties to any of these models after the chains have started running?
You mean update the core software version while the chains are running?
Yeah.
That is an upgrade process and needs to be handled with a migration.
Okay, fair enough.
Yeah, so I can't. That's a classic problem. I said this yesterday, and now I'm saying this today. Need to reconcile. So but basically the schema of the system is for the most part, that'll be the minor version of the software. So if you modify that schema, probably you're technically saying that the API changed. Everything else would just be patch version. So in a weird way, it meant that even though the schema was defined as one large JSON schema, and you can see the majority of the schemas in the file model schemas, you never actually in the running system ever see an object that meets that entire schema as an object. Like, you can create it for testing purposes. So I've added in this 2JS function on all those schema generated objects, but you never, for the running of it, you never really see that full object anywhere. It's all just arrays. Arrays go to disk. Arrays get loaded in RAM. Arrays, it's just, it's weird. Like I kind of, yeah. It also allows you to do schema validation checks when you change a parameter. I haven't decided if I want to run those checks at block time or if I want to run them on any given update. I got to go through all the models and see how, because I had that logicize function that basically checks that just because the schema is valid, there are some relationships between the values of the keys in the object that need to pass certain logic checks. And So I just need to walk through all the models, and as I convert them over, I'll be able to make a call on whether it's per key update or just one big bang at the end on import and on freeze or block making. So do you have that pull in front of you?
Yeah, I have it open on GitHub right now.
Okay, so in W15 source classes map factory is where the struggle is occurring right now. And the deepest version of a working thing is keypair.js in the same folder.
Okay.
But yeah, that's kind of it. So I guess the pattern I'm defining is that whenever you want to make a new object, you have to call the static method create. I locked you out of the constructor. So of the mixin, so that probably the hairiest bit is in map factory line 247 down is probably the hairiest, the most oddest thing. Because I basically made a static method on the class and then called it to add properties to the class and then deleted that property from the class. But I'm like, I don't know, well, because there's private methods, right? And they're great, but I can't access them outside the class definition, so I had to sort of do that sort of, pirate ship in a bottle thing, and then you pull the lever and the sails go up, and then you pull the string out and you're like, ta-da.
There's nothing really stopping you from doing the same thing again if you want, though, right?
Well, there is, because I call object.freeze on the constructor.
Yeah, fair enough.
Because I'm nasty like that. But
did that actually work?
Yeah, it works.
Oh, yeah, you call it on the... Okay, of course, for sure.
Yeah. And then I lock the constructor with this notion of there's a symbol that is created within this class, and if you don't supply that symbol to the constructor, then it throws an error. But I don't know if there's a nicer way to lock the constructor from being accessed. My intent is clear. The means, not so pretty. But
yeah, I mean, I can't think of anything.
Yeah, I couldn't find a way to make a constructor private or inaccessible, but this works.
You could proxy the object.
Proxies are slow, man.
Yeah. Yeah, no, for sure. I think it's the wrong thing.
So the speed tests on this show that it's about a 10x slowdown on just if you have a plain object and you get the property off it versus using the getter, it's about 10 times as slow. But given that, to do that a million times is 1 millisecond on a Pojo and 10 milliseconds on this class, it was a million gets. I'm like, is it that bad? And plus, you would for sure lose that on the diffing stage or the hashing stage if you didn't have this. If you had a million fucking keys on your object.
And how is it for writes? Is it slower?
I haven't benchmarked that, but I would expect it to be exactly the same as writes on an immutable list. Which is
ON, right?
It's O log 32N.
Okay.
So...
Well, that's right. There's some sort of weird tree behind those, isn't there?
It's a try.
Yeah.
But what I mean, that's pretty good. And the other thing I'm leveraging here is that actually within the schema, the properties don't just go on forever. There's only one place where there's an endlessly growing sized object, which is the network object that tracks all the chains that you're connected to. Everything else has a reasonably finite size, or it's temporary. Anyway, like there's a place where I have to buffer while the developer part of the chain flicks into pending mode. I have to buffer the requests that are coming in because I still need to drain the channels, because a system request might come through that would unlock the developer portion from being in pending. So I need to buffer those requests somewhere. That is just an array that grows. I mean, it could get really large, but that's fine. That's a direct Merkle array, not really a problem. But the point is, the size of the objects in terms of the list of the number of keys they have, I mean, it's all defined in schema, and so it's constant. And so basically that performance doesn't really matter because the list of number of keys is small. So goes the theory, right? But the tests I've run so far and the profiling that I've done on it is very promising. So I would imagine that the thing that changing that now, this having all the objects be backed by an array, if you want that to change, now is a good time to pipe up about it, I guess, because
I'm trying to run like game in my head here about it, like you. So this is used by absolutely every data structure in every chain, right?
Yeah.
Okay.
And it has very strong structural sharing. Very strong.
Right. Which is good. I mean, hopefully, for sure.
Well, the problem... Oh, sorry.
What, let me just kind of like sanity check that I understand what this is about here.
Okay.
When you turn this into an array under the hood, it's a sparse array where the key order in the model that you're using determines the position in the array, right?
Correct, except for the fact that it's not sparse. It's at class construction time, it is set, because throughout the schema, I do not permit you to have arbitrary keys on an object. Right. Now that's the one place where you can have arbitrary trees is the state object, which you get passed into your reducer. But within the system or within the block, you cannot just add an arbitrary key. They must all be schema defined, or it is an error.
Okay. So like basically they're like, this is static typing.
Yeah. Hard static typing, like not just TypeScript style guidance. It's like,
because it just seems like if you change the key order while you're trying to block stuff, you're going to end up with a mess.
Yeah. So what I do is I take all of the properties as defined in the schema. I then sort them lexicographically, and then I use that as the order so that the order stays stable. If you change the schema, as I mentioned, you need to issue an update, like a semver bump.
Right. Right. And if you do that, that's basically loading a new model. Right.
Yeah, that's a new block format that you just described. If you change that schema.
Right.
Yeah.
And like, does that affect like backwards compatibility on a chain as it's running?
That will need to be handled with a migration. There is a portion. I don't really do anything with it, but the config slice of the DMZ is intended to store the current version that you're running. So you can, when you go to validate through either replaying or creating the next block, you need to be using the same version. I imagine that an upgrade will be simply a system action that says upgrade on the next block to this version, and then the validator that has the unlucky job of being first to produce that next block has to do the migration, which may be large and it may be painful on the memory, but at least it's a one-off thing. We can optimize that if it becomes a problem.
Yeah. And then you're saying the model system is built in a way that the only thing that can grow indefinitely is like plain old arrays, like channels.
Yes.
Okay.
But moreover, last month I changed the channel protocol, and so even channels don't grow forever. They are only they are flashed. So whatever the channel is in the current block, it is only presented for one block, and then it's blanked on the next block.
Okay.
So even that doesn't grow forever.
So you need to inflate those from history if you want to respond to them now.
Technically yes, but actually no, because that's what I thought you had to do, right? But then the problem came, like when I was testing with like 20,000 chains, and the problem started to be, well, all of that past transmission of every action that was still in play became a burden that made the block be like 20 megs in size. So that's the problem. And then I was like, but what am I going to do? If I have to. So the first iteration of that change, I actually made it go back through history and fish up the blocks and then recreate what it had sent. Turns out, in actual fact, you don't need to do that at all, because a receiving chain gets an arbitrary number of interblocks all at once. And so it always sees what it was receiving sort of completely, as it were. And then I used to just use a channel index as like to refer to the action that you're applying to. I made it now block height underscore channel index. And so long as you're tracking on the receive side, so long as you're tracking the tip, so you're like, where is the tip that's been replied to? I think that it is strong in terms of you can't misstep the channels. I do need to do some more work to check that there isn't a way to be malicious and twiddle with the channel order and sort of make the receiving chain trip. But I am confident that there is a solution to any of that. It's basically a case of fine tuning as opposed to architectural overhaul.
Does the same thing happen to sends? Like, did the sends get unloaded right as soon as you sent them too?
Yeah, that's the best part. For this new model system, the sends are no longer in channel. At block time, when you're post-processing the block, getting ready to actually compute the hash and send it off, what I'm going to implement with this new model system is all of the channels that had something to transmit are blanked. And then only the transmission is pulled out and put into a dedicated array that's used for transmissions. And what that means is that the hash computation and the storage space required to modify the hash in the next block, when you would have had to blank all those channels, you now no longer have to blank all the channels, you just delete that single key that was sending and you're done. So it works out to actually save space on balance to do the sends from a dedicated object. It also allows us to inject obfuscating randomness within each channel so that you can't know anything about your neighbor. Because if we just left the neighbors as being hashed, if you knew the chain ID of one of the neighbors, then you could brute force check what the action was that got sent. But if you insert randomness within each neighbor, then you'd never know. So it allows us that option to, like, whilst in the mode we're operating now, it's not a big deal if you can detect what your neighbors were hearing, but it is nice to have a plan for that in the future.
Right, for sure.
So
I remember.
Can I ask a question, Tom?
Sure, man.
So is the channel in this block the block RAM in this instance?
So is it the block RAM? Did you say?
Yeah, is it like the RAM of the block where it's like if you once the block is done with that particular channel, it just deletes and then you just bring in some more memory.
No. The channel is the connection it has to any other chain. So
I would say it's closer to being a socket.
Yeah, socket.
Okay. No, but you were describing like an array, almost like a memory array.
Yeah, because what happens is that it wasn't immediately obvious to us, but when you have one chain that has a connection to 10 other chains, you don't notice the size of the data structure that's storing the information on how to connect to those other chains. But when that number gets up to, like, I started noticing it at about 7,000, then the size of the data used to store the information about the chains starts to get very big. And that's a problem because the block size starts to grow. And so I needed a way to make it only store the diffs in the database, or else it was going to it starts to bomb the database.
Right.
So,
okay.
Because we have these sort of performance goals of like a mega chain and then a giga chain, and I used to think that at around about 50,000 chains, we would have to implement a policy that's sort of like sharding for databases, where if I have one chain that wants to talk to 50,000 chains, what I need to do is actually make that one chain talk to 5 chains, and then each of the 5 chains talks to 10,000 chains, because the strain on the data structures was too high. Like the cost and time to compute what to do or which channel to look at low numbers, it's sort of so trivial that no one notices, but at those high numbers it starts to actually really bog the system. And so I actually think that using this current model, I can actually get one chain to talk to 1 million other chains as direct children without that sort of sharding model. But definitely for one chain to talk to 1 billion, it will need the sharding model where it has some intermediary chains that operate on its behalf.
Well, it's good to hear.
Yeah,
you can get mega chain without, like, because to me that sharding model has got to be something that's kind of in the application layer a little bit, right?
No,
like,
man,
you have to write that. No,
it can be entirely. The sharding can occur entirely at chain layer, because what you can do is take advantage of the fact that each chain ID is universally unique, and so you just allocate it to a particular chain based on its hashing. So, like, you got 10 shard chains, one handles from like 0 to fucking whatever, and then you split them up like that, and all you got to do at the chain level is apply some logic to sort of smooth it over so that the app thinks that its one chain is talking to 1 billion. But really, it's one extra step.
When you describe it like that, it sounds like clustering almost.
Yeah.
It sounds like a cellular network.
Like a cellular network?
Yeah. So, like, basically, let's say if you want a lightweight chain, you only want one chain talking to its neighbors, like maybe 2 or 3 other neighbor chains, and not the entire network necessarily, unless they need a validation or some other proof of something, and that way you're not getting all this traffic where everyone's always talking to a billion chains at the same time, and there's a lot of collision going on. It's just you're only talking to the immediate people that you really need to talk to, and that would be a cellular network, right?
Yep. There are similarities there. But yeah, just to close out your original question, Troy, the channels topic that we're talking about now is really about how many open connections can I have. Possibly the most practical example we'd all be familiar with would be number of open connections in a BitTorrent client. Once the number of open connections gets high, your system starts to bog, and if you had a crappy router, your router would fall over. That's the problem we're dealing with here, in that when the number of channels open to chains gets high, the overall system suffers some weird slowdowns.
When you say overall system, are you talking about the overall blockchain substrate, or are you talking about just your particular shard area, or
just the code that runs, the code that creates the next block has performance issues when the channels get high under the old system. Under this new system, I think it's good to go up to about 1 million children.
Yeah, but is that something that we would set up in the UI where it would be like default 10, and then if you need to go higher than that, then a user could set that?
No, we'd make that choice for you, probably.
Okay.
Yeah. Yeah. So that's where we're at, Ben.
So it sounds like the main thing here is like this is just turning more, like using an array allows you to turn more things into smaller diffs more frequently.
Yeah, man. And what I started to realize. Sorry.
Is there any risk that that's going to result in you needing to do like infinitely long lookups to figure out how to resolve something when you're blocking? Like, is there any risk that like you're going to have to look back millions of blocks?
Yeah, absolutely. Remember how I used to fight really hard for the developer to not actually be able to find out their own chain ID? And I wanted that to preserve things like you shouldn't be looking up. You're like, why are you looking at your history anyway? Like, what is the use case of it? Now, sure, you could concoct some, but as a developer, yeah, you might not, you probably don't need your historical blocks, generally speaking. But as a user at the front end side of an app, might, for arbitrary reasons, like the user might want to just see what is my history, what did the thing look like. If you're in the workbench and you want to do a fork, you want to go back to a certain time, right? And you can't have the database being like, my goodness, you have 200,000 blocks. Wait right there while I retrieve the diffs from all of them and patch them all. So what I've figured we would do is that at the system's discretion, it would periodically store a full block, so that when you need to retrieve history, you can fast forward to one of these snapshot locations and then replay diffs from that point up. This ties into the when validators talk to each other, they need to have a different set of protocols to ask for data. So you need to be able to say, hey, I want block at block height, blah, or I want all the diffs from height to height. And it's also very useful for them to say, I have up to height 10. I want now all the diffs up to height 20. And so what that would mean is the validator serving that request would actually, they don't have that data available, so they would take it upon themselves to compute the diffs for this requesting validator. But they would need to have had the blocks. So the fact that this data structure means that you can sort of roll forwards and backs, and you can like reinflate anywhere you like, and then you can sort of pick a block and go diff, 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 and you haven't really punished your RAM any more than what the diff was. So what I sort of realized with the database part was that the key to performance is having a good cache, and without structural sharing, if you're trying to, like, the blocks take up all your RAM really fast. But with good structural sharing, it doesn't sort of sweat at all. And so you get this great cache performance where everything's just coming out of RAM, but your RAM stays sort of basically logarithmic in size. And then you can eject from cache anyway, no problem. And just what you currently want to keep around stays around. So those were the characteristics I liked about this model.
Yeah, no, I mean, it sounds good. I haven't grokked it completely yet. How can I? So it seems like testing some of this stuff would be really useful right now.
Totally. I mean, my philosophy has been just doing tests enough to get it working. I have noticed that there's a good sort of a plateau quality about the system, where if you see the tests that are in under W18 standard engine, those tests basically fire up the full system and then do some particular property, like send out some promises, use the loopback channel, all that. What it appears to be is that if those tests pass, then the whole system's pretty good, because the number of things that have to go right for it to produce 100 blocks, and they all have the correct sort of end result, the correct block count, all that, strangely seems like that makes me feel safe that the system's working correctly, because the fact that it reuses so many parts of itself on itself, it's the most depressing thing to add a new feature to, because it breaks completely from the smallest feature change, and then you have to build it up as you ripple the change through, and only then does the whole system work again. But once you get past the depression, the upside is that it's when it's working good, and it's not
it's a self-reinforcing design, right?
Yeah. And the downside is that until you're actually at the working point, it's fucking horrible.
Yeah.
Testing. The major features that I need to add are pull requests. So, being able to operate on a tree of chains and then to fork the entire running state of an application and have it only modify the chains that have changed. So if I make, for example, a CRM and I have 100,000 customers, and that's the production version of the CRM, and I want to run some tests, when I fork it, I want my fork to only consist of the diffed data, the chains that changed. I also want to be able to stay in sync with production. So periodically, if production altered, I want it to automatically update unless I have modified one of those chains, in which case keep my modified version and ignore the incoming update. And then finally, when I'm ready, I may wish to do a merge back to the original application, where I want a tree of arbitrarily many chains to then be merged in as an atomic operation with the running system, after having passed some logic checks.
As an atomic operation sounds like a tall order.
It's doable.
Is it?
Yep.
Because, can you, it's validators that would be merging stuff, right?
Yep.
And there's no guarantee that, they're all operating on the same set of chains, is there?
Oh, you're talking about doing a pull request that does a merge where the chains are owned by different validator groups.
Yeah.
I don't know how to do that, but if they're the same validator group, yeah, we can work. But I don't know.
Sorry. So, what do you mean by atomic? Like when you say atomic, I'm picturing many chains going through an operation together, and if any one of them fails in that operation, all of them fail.
Yep.
It,
If all the chains are operated by the same validator set,
mm-hmm.
then the validators can do that merge as one shot.
Right. And they can fail everything for one thing failing, basically.
Yeah. And so there's two ways that you can do that atomic merge. There's like atomic merge that's sort of forgiving. Like you're like, I want this merge to occur, but if some changes occurred in the meantime and they turn out to be trivial, then go ahead and carry on. Or you can make the merge hard, which is like any change, don't care how trivial, anything at all. If it changed while the update was happening, fail. And then, of course, you need the ability to lock the system from receiving updates while the atomic updates rolling through. So there's that piece as well. All of that's doable so long as you have a single validator set controlling everything. I will need to have a think about how to manage multi-validator sets. It may be possible, and it may be possible if there is goodwill between all the validator sets, but it may be impossible if someone decides to be a jerk. And it may be that only one member of one validator group needs to be a jerk to derail the whole thing. I need to think more about that.
Yeah, I guess so. The type of merge you're talking about now is probably one that is happening to a solution of chains that have a common parent.
Well,
so there's
the concept of the root chain of the app, which mm-hmm. I've only loosely implemented here, but what I figured out was that every chain, there's always a root, and a root can contain within the tree something else that calls itself root. That's fine too. But in terms of what that means is that for all the children, all the ultimate children of that root, the root is used as the point of synchronization in their communication with their siblings of arbitrary level. And so particularly for queries, the root matters. The root also matters for getting access to the chain. So you can set your access control to say something like, look, the root said I'm allowed into anything. So all I got to do is go knock on that anything rather than ask the parent, to ask the child, to ask the grandchild to, it can make access control a lot more rapid. But most importantly, it allows you to do queries that are reproducible because they're queries based on a particular root. And so the solution, I believe, is that every single chain keeps within it a special channel that refers to root. And every time you make a new block, it's the validator's job to include the latest hash of the latest root, so that in that sense, you can sort of guarantee the strong relationship to root every time you block. So when a chain makes a new block, it's in reference to the surrounding state of the system as defined by this root hash. And a validator that's doing a replay should reject a child chain that was created with a out-of-date root that's too far behind, because it's like, your overall system state's lagged. You are bogus. Don't talk to me, or something.
Yeah, that makes sense.
But it's just a way to allow every block to state that when it did a query against another chain, so you wouldn't be able to get any evidence whatsoever that it happened because it's simply a read. it is reproducible because it's in reference to a particular root, and that guarantee is strong because the children, every time there's a new child, you are obligated to update your parent as to the changed meta hash, state hash, and binary hash, which then in turn updates its parent all the way back to the root. And so the root that I'm talking about being referenced is the most recent root that received the complete tree down to you. So from the last block that you made that managed to bubble all the way up to the root, that's the root that your next block is going to be made in relation to.
Yeah. I mean, that makes sense.
Yeah. And what it means is that your queries are strongly guaranteed. Like you're guaranteed that you can replay that query because it refers to one and only one system state. Troy, just for your interest, you were asking how I was talking about one hash to represent all the world's data. That's basically taking that concept out to its extreme. Also keeping in mind that doesn't guarantee any kind of hierarchy. It just means that you're attached to some tree at some point. There could be multiple views of all the world's data.
Well, I mean, you were referring to snapshots earlier where, I mean, I don't know, it's probably not correct, but the snapshot could be just some sort of a persistent emit array, a lookup table, if you will, that's persistent that no one can modify. It's immutable, but it would keep tracking back to the root chain. So you'd have these snapshots on the blockchain substrate. So if I go, hey, I need to know something about this particular chain, I'd go to the nearest snapshot that is pertinent to my chain, right?
Yeah,
and that
based on that root hash, I go to the nearest snapshot of the chain I'm referring to relative to included in, the root hash that I'm holding.
Correct. And then that snapshot might tell me to go to another snapshot, which should tell me to go to another snapshot, which maybe thousands of snapshots later, I'm finally back to where I need to go in order to start coming back and syncing, correct?
I hadn't ever thought of it like that before because I would only considered the narrow case of doing queries within your own application tree. But if you were to query outside your application tree, then yes, absolutely, you would need to.
I'm thinking more along the lines of larger global validation. Like we were talking earlier about how to get separate validators networks to agree to each other. As long as they agree with the snapshots, they agree in principle.
Yeah,
and they can't be dicks.
That's a different level. The way to get the validators to agree is because the validators were chosen at random. That's sort of that kind of area that you're talking about.
No, yeah. What I'm saying is that, okay, so let's say I have validator network A and validator network B, and they're kind of running in their own ecosystems for a while.
Yep.
But they are broadcasting outside there and getting snapshots from other chains every once in a while.
Yep.
If these two validator networks wanted to come together and merge a chain, they could at least go back to the least common denominator snapshot and start from there, and at least agree on that.
Yep, absolutely.
Yeah.
Absolutely.
Okay.
Yeah. Yeah, so that's so what do we got? We got pull requests need implementing, the root, that roll up to root needs to be implemented. I think you can't have snapshots without that. You could have a sloppy snapshot, but strong ones need the root.
As long as the snapshot's persistent and immutable, and it's the proper lookup, it's got the correct emits where people can query it accurately, then I think that would be the dirty version.
It's dirty because each of the chains could have moved forwards from, it's hard to replay the query if, say if a year goes by and you want to replay the query that was run a year ago, you need that root hash to be able to guarantee that that's the snapshot you're talking about and querying against, or else you're...
I don't know. I mean, it's no different than, to me in my mind, it's no different than looking up for a book in the library, right? I mean, as long as you start with the right book, you might be able to track who checked it out from just the names inside the book. It's going to be hard to do, but you could do it. Like that would be the brute force method of tracking people down.
Yep.
I mean, and maybe you just kind of like set that to the side and say, well, it is what it is. It's going to be a few days, and you go, okay, well, whatever. I mean, I've waited like 3 or 4 days for Bitcoin to update. Why would it be any different from any other blockchain if that's what I have to do?
Yeah. So there's also another type of so the features that aren't implemented yet: pull requests, that root strong root hashing or root structure. The third feature is loose chains. So the root hashing deals with the root hashing gives you strong consistency, but there is a use case for weak consistency, which comes in the form of like a long running query. Where like I'm running 2 application trees, they aren't connected strongly to each other, the validators have intermittent connectivity, they really don't care about each other, but I want to know who's talking about popsicles, and these long running queries would be ones that they aren't strong, they're just best effort. And they sort of crawl and they attempt to find something, and then when they find it, they bring it back to the application tree, and it can make a decision on whether or not that meets it or not. It's kind of like the sort of like a multicast packet in a way. It's just there needs to be a defined way to break all the strong connections in order to access like mega scale data. You can't do it all with strong connections. You need this loose discovery.
Oh, yeah. I mean, that's what Google does, right? They just look through the metadata mostly. So, I mean, you want to do a meta-analysis on everything, right? That's your loose query. Where like, oh, you don't care about the nitty-gritty of the block. You just need to know the surface layer information in order to get the information that you want to do a search, right?
No, it's different to that. It's it needs to be of a specific format, but remember, Ben, we used to talk about DHTs as being a means of doing a lookup for validators or for particular chains. Mm-hmm. It's sort of that sort of thing. I think it's defined in the dictionary as there's like this concept of an inbox, and hang on, let me try to find the exact topic that it's talking about. The weak link. So in the Dreamcatcher user dictionary, in the contents, item number 3, the weak link hasn't been built yet.
We're going to get that open.
Shallow forks was what I was talking about before. Deep forks hasn't been done either. Deep fork seems easier than shallow, where you're just like, I want a fork, I don't want to fork everything, and I never want to talk to that previous motherfucker again. And
so you're talking about a clone, right?
A deep clone, not a shallow clone.
Right.
What else have we got in the dictionary that's not made? And terminus forks and merges. So being able to merge and then destroy in one operation. So it's like...
So merge and self-destruct?
Merge and close the incoming branch so that it can't be modified any further.
Okay.
I think you should leave it always chaos mode.
It can be reinvigorated, but it's like, you know what happens in GitHub where you get all these branches that are just open and they sort of go stale. And it should be considered an error if this particular chain has said, I am now merging with this other chain. It should be an error to try and contact it again. I believe.
Right. So it's there for query, but not for activity.
Yeah.
You can't connect.
Yeah.
You can't connect to it through your channel.
That's right. Yeah, and you can refork it. You can refork it and start again. But the point is that without that operation, it will just reject you from. It's dead. It's gone inert. It's not able to make its next block.
So there's some sort of high level kill switch in the block chain itself.
Yes.
Okay.
And there's like, I assume that one uses parents, right? Like everything has to go through a parent to eventually contact the chain you're talking to. The parent would be the one that's saying no, like nothing, no more blocks can be made on that chain.
That chain could be a root chain of itself, and it's simply saying it's got a flag set in it that says that the validator will reject anything that's trying to cause it to make the next block. It's like this toggle switch has gone to, it's halted. It's completely halted, and you can restart it with a fork, but you can't keep treating it like you used to treat it.
Mm-hmm.
The halt and catch fire switch.
But look, I think that's all the features that there are that are missing at the moment. Oh, consensus.
Oh, just a little tiny thing, right? Just a little itty bitty feature.
Yeah. But to be fair, right? Like running singular consensus is still a commercially useful thing, which people are paying for. So, that just makes it run like a traditional app where you're like, this computer is the boss, and this computer said, okay, great, let's get on with our lives. But
that's just command and control, right? So server slave. Yeah.
And so what I started to realize was that with implementing Tendermint BFT, it started to matter less because of the political design that I want out of the inversion token or the currency of it. This ability to pick a validator at random doesn't fit well with the Tendermint algorithm. The Tendermint algorithm is based on a fixed number of validators, not a randomly selected group. It can be used within that randomly selected group to reach consensus, but part of why I haven't done consensus is because having a fixed set, a fixed number, isn't as useful.
Does it have to be fixed? Like, can it just be a critical mass? Like, if your consensus algo basically says, hey, there's no consensus here until I hit critical mass of enough validators saying yes, no, true, false, whatever it is, would that be enough?
No, because what I want to happen with the I guess let's call it mainnet or the public net, is that it's the chain itself that predictably or pseudo-predictably selects the next validators for any given chain. And so when you store that validator set in the actual chain, you can't actually know them ahead of time. They will be selected from a pool some point in the future, and you can't just make them be anyone, because you need to force the diversity of the validator sets so that they're not selected at pure random. They're selected with distance or other parameters to make sure that it's getting spread around the pool in a way that the ability to defraud a particular operation goes way down when you do that. And so from that point of view, I'm not sure that Tendermint BFT necessarily applies here, or we will need to modify it to handle that different type of operating mode. I'm just basically saying why I haven't done consensus and why I don't think it matters until later. It only matters for the currency. Getting the actual chain up and running is very saleable as just we are running this piece of software. We say what the blocks are. That's plenty. And as an application developer running on that system, like as soon as we upgrade to a more decentralized algorithm, like your app won't even need to change. This whole stage we're at now is just how do we get the system up and running so that we can prove that you can make apps in this way and that those apps take less code, less effort, and less thinking to make any given application. That's actually the real prize we're trying to hit. Once we have that, and I do believe we do now, even though I've only made 5 apps, but they are still apps that would have taken a lot of time traditionally and would not be reusable or composable between each other. And so I think it's demonstrated the tree-based system, this one blockchain per object system. It's shown that it works in a browser performantly. It's got storage, it's proven all those things. So that's commercially viable. People will pay for apps built in that way. And now we can move on to doing the more exotic things like actual decentralized consensus, which is hard, but you don't want to have to do it twice. You kind of want to know the system that you have, and then you want to do consensus to fit that thing, because you're not changing it once it's in. You're absolutely not going to change your API or your system without completely breaking consensus. So that's why that's slated to last.
Okay.
Yeah, it actually makes sense. We need to be the authority on how everything runs because we need to be able to unfuck it if we wrote a bad API.
Yeah.
And you can't unfuck it if everybody else is running it, right?
No.
There's no pause button.
Yeah. And, when we start to introduce money into the system, either for tracking money as an accounting system or for connecting to the Ethereum chain, we need to have a gateway that's human operated for a while that says that, one of us has to sign for this transaction to be broadcast to the Ethereum network because we simply don't trust our software.
Or multi-sig, definitely.
Yeah, we don't trust our software enough to be able to operate in fully freedom mode. But we're going to get there. It's just we have to go through these stages first. So I guess, sorry?
Is there any thought yet as to what constitutes a solid enough protocol and base layer for free operation?
You mean when is the application interface stable enough to try and do or move on to doing?
It's a little bit more than that, I think, too. How much of Dreamcatcher needs to be done before you want to start allowing open validators?
That's an interesting question, and it's interesting for two reasons. The first one is the capability or the ability to actually make such a system and make it stable. Now, I don't have that ability on my own. You and I together have more of that ability, but I still don't think we have enough. We actually probably need half a dozen other people that are actually reputable auditors that actually know what's going on in the system and in different realms of security. It's an expensive job, a hard job, and a long job, and I don't want to tackle that job without having the Dreamcatcher in place to manage the equity split or the attribution split, the royalties that go back to everyone for making those kinds of contributions.
Mm-hmm.
Oh, that's off channel. Sorry, no.
So I just wanted. I'm just mostly just saying this out loud, not necessarily to you guys, but basically you want an alpha version that's a workable version that us fourish and or other people that are coming on to bootstrap this can start working with the infrastructure for equitable distribution, right? And then you want version 1.0, which would be open validation or some other quasi version of that, right? Where it's more of a prime time sort of whatever interfacing with.
Correct. So
then maybe a version 2.0 where we're actually bridging to other chains and doing much more intricate DeFi and apps.
Yeah, or preferably the other people have started to do that for their own self-interest and are coordinating with us as a whole. The system I want to get off the ground is one where come one, come all, you see something that needs doing and you can make some money for yourself from it through this attribution system, go ahead and do it. We don't have the time or the skills or the money or the whatever to be the ones doing all the work. We need to make it extremely enticing for other people to come in and do it, but we cannot do that with false prizes like what I see many chains doing, where they raise a bunch of cash, they get inflation for their token, and then they spend that money on incentivizing work on their networks. That is like handing out fucking candy at exams for people to try and work better. Like, it's just not gonna, it's bad. It's not genuine. It's not sustainable. It's not organic. We need organic, genuine, sustainable growth. And that can only come from a coordination system that makes sure everyone's treated fairly.
You need the money to come after the work, not before it.
Yeah, because it's false if it's money first. Now, that's not to say that we aren't asking for investment to then, to get things going ahead of time, but you can't build an ecosystem off investment. You sort of need it to be not you doing it. So that's the first of two reasons why I need the Dreamcatcher operating before we hit true decentralization for the chain.
Okay, so what I'm hearing is that we need a minimum systems requirement list. Then that's what we really need. What would be your minimum systems requirements list? You don't have to answer that right now. I'm just throwing that out there because that's
the dictionary. What's listed in the dictionary, the features described within the dictionary. The software needs to be able to support that for the minimum version of the Dreamcatcher to begin to operate, and for us to use that to further the expansion of the software and the ecosystem.
Yep. Okay. So that's what you're saying as the minimum system requirements. That document.
Yeah.
Okay.
Sorry. Oh, not quite. Like, that's to be able to fulfill the requests in that document would be the minimum system.
Okay. Great.
It's not directly saying what the minimum requirements are. And to be fair, there's like a bunch of things that I'm bumping into here and there, and will continue to bump into that I didn't foresee, like performance bottlenecks. Now I know how to put up a metric for database performance when a chain has, say, a large number of children, right? We'll keep adding these new metrics that sort of define.
Yeah, but those are known unknowns. Those are. Yeah. We can handle those as they're coming, right? So It's the unknown unknowns that are the issue. But I'm just saying that if I'm writing this requirements document and I'm putting in the minimum system specifications to get alpha version running, then that should be at least a tentpole to go. And we can. It's a living document. It doesn't matter. It's not like that's it. It's set in stone once we have those requirements. I mean, of course, we can always add. There's always testing and validation, but testing and validations is not part of the specification. It just all it does is track back to the specification that you did what you said and you said what you did, that kind of thing. So, that comes later as well.
To make the minimum version of the Dreamcatcher run is the spec for the blockchain software to me. I don't want to tackle the big stuff until we've got the Dreamcatcher running in alpha form, because I don't want to have a bunch of fucking debates about how about I have this many shares or this much percentage or whatever. It's like this is the attribution algorithm is the key thing that we're building. All this other work, the blockchain, the Dreamcatcher, everything is just wrapper and like foundations and supplying resources to allow that algorithm to flourish. That's the thing that we're trying to make.
Right. Yep.
That's the first reason. The second reason is that the Dreamcatcher itself is intended to be like, I just don't see the point in making the world's greatest blockchain and then releasing it. I'm not saying that this is the world's greatest blockchain. I am saying that the world's greatest blockchain looks a little bit like this. Like, it has these kinds of properties, like, to sort of ignore what we're doing. There is a blockchain coming that is the world's blockchain. It will have trillions of chains. They will all talk seamlessly. Transaction costs will be measured in millionths of a cent. You will be able to move between validators, countries, your phone, your computer. All these things are coming. We know that we hit some of those features. There are many features more that need to be added to hit that ideal, but most importantly, in that ideal are contained a number of unknown unknowns. And we don't know what they are, but they will be hard. They will have large sweeping architectural changes required to meet them once we hit them. My overall point is, it's dumb to make a great blockchain and then try and own it. What you need is the system of self-improvement that gives you the maximum rate of increase. You also want to make it so that anyone else who's sitting there with a great idea on how to make a blockchain doesn't go and make their own token. They do the math and say, actually, it's more value to me and less effort if I just modify this other one, right? So that is the kind of environment we need, where we can't rely on ourselves to have enough innovation to make that perfect blockchain. It's just not going to happen. What we can do is build a system enough that can modify itself by inducting the innovation from other people around the world in a way that's predictable and fair to those who are new and those who are old, and balances the requirements of paying for effort done versus enticing effort to be done in a way that helps it grow. Like, that's the reason why I don't want to tackle that really hard problem. I don't want to have a global token. I don't want to have a currency until we have a strong Dreamcatcher base, because we'll just lose. Even if we were the winners for like 6 months, and it's a big if, because there's a lot of blockchains out there, but even if we were the winner for 6 months, without the Dreamcatcher, 6 months later, we'd be just nobody too. There'd be someone else would have taken all the good ideas that we'd put in, all the hard work, and just gone next gen, right? And off they go, right? But it's, even if we start as sort of not that great, but at least it works, if our rate of change is better than anyone else's, we will very quickly overcome them. And in fact, it probably won't even be us. It'll be us plus whoever else we can attract along the way. That rate of change will continue to grow and will eventually eclipse everyone. And when people look back on how the chain was when it first started, they'll probably laugh because it'll look nothing like it. But the goal is rate of change.
Yeah, well, I say the same thing with iteration. Like, you got to iterate fast and often, and you got to fail as much as possible, as quickly as possible, to get to the correct solution.
Yeah, and I think you got to draw on the biggest possible pool of innovators to get that done, because you don't want to only be able to draw on your employees, because that's guaranteed to be slow.
Well, employees is just means a moat. That's, those are turf wars, right?
Turf wars, yeah.
Our employees are better than your employees. That's all I hear when I hear.
It's so dumb. It's so dumb. It's like, it's just comes down to the code, man. Like, make good code. Get a piece of the future on it. Yeah.
I mean, almost everybody who's a Silicon Valley billionaire stole their code anyway, so it's not like any of them have any original ideas. Facebook stolen, Google stolen, Microsoft stolen, Apple stolen. Like, it's nothing's original.
Yeah. So anyway, those are the two reasons why your question was, why the Dreamcatcher when. I mean, did that answer your question, Ben?
That wasn't my question, was it?
Yeah, you were asking about tackling that base chain. Like,
Right. So it doesn't really matter, I guess, is the answer. Like, consensus is not something we're going to think about until we've got enough of the actual governance mechanism down pat. The chain needs to kind of own itself, right?
Yeah. I mean, look, you're welcome to chuck in a consensus mechanism. I'm just telling you why I didn't yet.
It's actually probably the least interesting part to me because I know it's super annoying, right? I mean, I've spent enough time reading consensus algorithms to know that there's a lot of like tiny details that are.
Oh god, it's so annoying. But Troy, there might be something that you'd probably be really good at is an incentive audit on all the actors that would operate in that mainnet and who is incentivized to rip off who and how, and all those kinds of issues. The social and political issues around the consensus mechanism are more worrying to me than the actual technical aspect of it.
Well, I'm kind of a bridge to that because I find them both fascinating. So yeah, I'm right in that wheelhouse, man.
Yeah. Because we need to basically, it's going to be a bit of an oddball consensus mechanism because it'll be using actual useful work as its fortifier, and so the questions will be raised: who can rip that off and how? So we need to be able to have a model that proves that that's safe within these constraints.
I was just thinking that the other day as I was like mentally prepping for this meeting is why doesn't proof of work use like real work and not just imaginary work?
Yeah. Well, it's a coordination problem.
Theoretically, it's using work as heat, so it's joules and all that. But yeah,
right. But like work in the more human sense of like this is
right.
This work is done
actual
further
proper
along
effort, right? Actual human effort.
Well, towards an end that's useful.
We are going to absorb that as well, but the main, so even just computers doing work, like it's a massive coordination problem to have each computer do something slightly different and then coordinate back to sum that all up and make it a total amount of work. I think we've got a workable model here that takes advantage of the multi-chain nature of this thing to segregate out the validator sets down to just those validators that care about a particular ledger or money trail, and then allow it to roll up.
The work that we're proving here is work that like consumers actually want to have done.
Yeah, someone actually wanted it, and as a side effect, you strengthen the currency overall. Where
I have that in the requirements document as a proof of effort token. So
right, but there's another level to that which you guys are touching on when you talk about human work, and it's that there is a lot of operations that once the Dreamcatcher gets going. Well, let's ignore that. Like in GitHub, for example, there's a lot of people making commits to master branches that are highly, highly regarded and guarded by other people. And, there's hundreds of thousands of pushes to NPM of critical packages every day. Now, what I envisage happening is every time you make a key commit to something that has a high level of reputability, trust, or value in some way, that you would also, as a side effect, add in the hash of the top level block that you support. And so you can start to add another layer of strength to what is tip in the mainnet by other people who are using the system for high trust things, also stating the next block is this. And so if you imagine all the commits to master across GitHub in a day, there's probably enough that there's maybe one every few seconds. And so every few seconds, you would be getting a high value commit that also supported the tip of the chain, whichever it may be. It's really just about correctness of computation. So the base layer is just pure CPU work. That's what I want to tap into first. Then above that is the social level of trust, because that's really all you're using the computational work to discern anyway, is do I trust this thing? But we can put those extra layers on there as well, so it becomes even harder to undo. So for you to roll back a mainnet block, you not only have to redo all the computation work that went into fortifying that block, but you also have to somehow override all the valuable trusted commits and signatures that were added from people as well. So it just sort of, it's a way to make so many layers that you're like, look, don't bother. Like, just stop trying to wreck it. Just get on and do something.
So
useful.
Basically what you just said to me in my mind is that if you want, you can go ahead and try and rewind a blockchain, but you're going to have to forge a whole lot of signatures.
Yeah.
Like actual individual signatures, like from real people, not just one. It's not that you can have just the private key to one individual. You're going to have the private key to like hundreds or thousands of people in order to roll back a chain. So
and you need the CPU power to keep up to pace with the proof of work portion of the proof too.
Right. So you need the resources and the forgery.
Yeah, which is sort of like at that point you're like,
who cares? There's only one country on Earth that would be able to do that at this point, and that's China. So.
Yeah.
It's only people that would be able to have enough people to throw at it and money and to throw at it in order to even have an attempt to do that. So
yeah, but I mean, like the system overall, the mainnet is meant to be designed so that China can fork. Like China can fork mainnet and run completely fine, but the key to the design is at some point later they can merge back and we can all get back to being friends or whatever we are now. So it's about embracing forking and embracing dissent or disjunction in a way that highlights simply the difference and allows you to reconcile at any point. Now, if we look at the major blockchains happening right now, they see forking as a problem. It's not part of their core feature set. It's not, like forking blockchain, you want to merge it back. I mean, what does that even mean, right? So that's I guess that's what I'm getting at. Like forking should be considered normal operation, encouraged operation, and merging as well.
I really like the vision of it that, like, if I want to make money, if I have a good idea as a developer, like I can literally just add it to an app, and that might become the actual version of the app that everybody uses.
Yeah.
Like, and everybody else will still get paid for it.
Yeah.
But so will I.
So will I, right? And so at that point, you've caused an incentive to come together to present as one is now worth more than to present individually. Whereas right now, forking it's almost you're incentivized to fork almost.
Mm-hmm.
And I think that we lose a lot of value that we could capture and deliver because we're not concentrated in what we're trying to do.
Yeah. Yeah, I mean, I think personally, like probably the secret to running a really big tech company is being really good at indexing code. And like, we don't have any systems that allow us to collaboratively index code very well. I mean, we have GitHub and things are public on GitHub, but there's no reason for me to use this library or that library.
Right. Right. Yeah. There's no actually monetary incentive to cause you to want to merge or to suggest merging or to, like go and do some work on a popular library to get paid. Like,
and in fact, most of the forks that I've seen of popular libraries, they live entirely on my computer or in my monorepo as like something that nobody in the outside world will ever see because I had some sort of like bullshit problem that it wasn't worth my time to try and convince them to fix.
Not exactly, right? And so here's an incentive to make you want to fix it or you might become the dominant form. Either way, everyone's cool and everyone gets paid.
Right. But I mean, if you become the dominant form, like, guaranteed everybody's going to be chasing you to merge then, right?
Yeah. So I guess that touches on what I would term a pure Dreamcatcher project versus a traditional project. A traditional project has there's permission on the master branch that's held by a person or group of persons. And if you want the app to change, you need to pull requests against them. They may or may not let you in. With this incentive model, they are more incentivized to actually pay attention to your merges because they might make more money if they're more compatible. And even though they got to share a bit with you, overall their net return goes up. But what I would call a pure model is one where there's no privileged master. There's some version of the app that the consumers are pulling down and using. When a new version or a new pull request is created from anyone, that option is presented to the consumers. Most of them may choose to ignore it. Some of them would be the power consumers. Some of them would say, actually, let's run with this new version and see if it goes. They would switch. In that case, you start to allow the consumers who maybe they start to follow people of high reputation, and so they define master by a reputation calculation or a usage calculation or just something that isn't some dude that makes a decision arbitrarily. Like, screw that guy.
There is a model for this already exploding. Like, there's this everything you guys are talking about. I'm seeing firsthand in smart contracts. Like, all of this, the forking, the reputational issues, the security issues, all this stuff. It's like how people are becoming subject matter experts overnight, and people are like flocking to them because they're so good at what they're doing just by reputation alone. And everybody's just like, oh, what he says is gospel, or what they say is gospel, and people are using their libraries because they have such a great reputation on the smart contract network. That's all happening right now. It's just not captured anywhere, and there's no attribution to it.
It's not in band, right?
Like, if I write a smart contract, I'm always going to copy and paste someone else's code, and they don't get credit for it, right? If I use a library, I'm going to probably be using stuff from Open Zeppelin. They don't get credit for it every time that smart contract runs. No. It's just their name just appears at the top saying import from their GitHub. So this basically tells me that I could write a smart contract on Dreamcatcher, and then if I import someone's library, they're going to get a cut.
Yeah.
From that run.
And most importantly, when you deploy a smart contract to Ethereum, I think that the miners should pay you something because you caused usage. You made them money, right? And so being able to just make money from simply making useful code that got run on mainnet should be enough of a business model for you to sort of raise money and focus on, right? But it's not right now. You always have to distort its pure utility with some type of capture mechanism, and you have to do it on your own. It's hard to do it in collaboration with a larger group of module owners or contributors that can form a useful app and then split the cut. So we're basically trying to provide that mechanism of making it almost inevitable, or like a gravitational pull towards combining and producing a single unified feature out of multiple components, whereby we, through code, predictably manage the attribution mechanism so that everyone gets a reasonably fair slice. What fair is will need modification over time, but at least if it's data-based and rule-based and predictable, that's first of all worlds better than what you got right now, and ultimately we'd hope it would converge closer and closer to something more accurate.
Right. Oh, one question before I forget. When I haven't seen much of the blockchain actually running, but what constitutes block space right now in your head? Like, what are some examples that actually things and objects that create block space?
And you would need block space. Do you mean like the term chainland that's used throughout the dictionary?
Maybe. I'm just saying, like, okay, so on Ethereum, we're competing for block space by the miners are selecting things that go into the actual block, right?
Yeah, that's an evil game. There's no such competition here.
No. I understand that. I'm just saying, but so even if I'm running an instance on my laptop, right?
Yeah.
If I'm running an instance on my laptop, what would I be doing to trigger block space? Like, what would I be doing that goes, oh, by the way, this has to go into a block. That's another block. And then I do
it
this.
Could be anything. So if I make, let's say we make the Dreamcatcher app, and you're using it, and you've agreed to turn on telemetry to help us improve the app. So we would then be capturing your mouse movements in a block. As soon as you move the mouse, a block will get made on your computer in your browser. It would then make a decision to send that block to somewhere that we can access it, or connect to another chain that we control so that we can get access to it, something like that. Anything at all can trigger block activity.
Right.
From the point of view of if you thought about it like a traditional, just an app that you're looking in your browser, like that one I showed you that time, when you click on the tabs in the single page application, just changing the tabs makes a new block. So the entire GUI was being, you click, it dispatches an action to the chain that's running on your browser. It makes a new block, and then the UI re-renders based on the contents of that block having been changed by the action you made. So right now, to make a block within your browser for doing something like that is around about a 22 millisecond step. I'd expect once this new model system goes in, it'll probably be around about 5 to 6 milliseconds a block, which is pretty much who cares at that point. Like, it's fast enough to not worry about. That's with basically everything. Every type of activity makes blocks. The question is, how many validators do you want to validate those blocks? So for your browser operation, there's no point, calling on like computers from the 5 corners of the earth. It's enough to just run it in your browser. But for something more like for a CRM type app, you might want at least the company server or the company delegated server-like computers to agree to the next block if you want to update a customer record, for example. So that would take a bit longer because there's like first the block in your browser needs to be made, and then it needs to know that, I wanted to change something, so I need to send a message to one of these validators in the company server room. The company server room looks at it, makes its next block. That block gets broadcast back down to the UI, and then the UI updates accordingly. So was that kind of answering your question?
Yeah, to a point. Like, I was just wondering is that tunable? Can you tune that? Like up or down, depending on how much granular you want in terms of.
Well, typically that's selected by the developer. So the developer decides things like what validator set am I going to run on? What does quorum look like? How many validators need to agree before it's considered a valid block? So that's all developer specified. As a developer, I could allow the users to alter some of that themselves. I'm still not sure I got what you're asking.
Oh, yeah, you are. I'm just saying, like, is there a way where I would only make it where, let's say, I would only create a block if I hit save, for instance, that kind of thing, or go to a new website,
Absolutely, that's a developer chosen decision how you want to hook the app up to the block making process.
Yeah, I'm only bringing this up because, like, I still see this as being a bolt-on feature for a lot of ingrained infrastructure out there that needs stuff to be able to run in the background and bolt on to existing applications still. So, because I still think that's going to be a huge market that's untapped for a lot
absolutely. I mean, one of the biggest companies we're dealing with at the moment is the concept of being the enterprise message bus is probably the major thing. So in a typical enterprise, you've got like a handful of apps. If you want to integrate them between each other, you've got like n squared over 2 connections to make. You're not going to do all those, so you're going to pick a handful of them. But with our system, I'd imagine what you do is you make a connection between that particular app and this blockchain, and then if you want to push into another app, you make it via this blockchain. So you basically take the number of connections down to n plus 1 instead of something that's squared, and then you also own your data sitting in the middle of it all. So you're like, by communicating with these other apps, you're also extracting their data out and making it your own and using that as reference, not the app. So I see the strategy as being like a surround and dissolve type of thing, because once you're managing all the I/O of any given app in an enterprise, and you can predict what comes next or make simple logic that removes the need to even make a call to that particular app, it makes it easier to replace the whole thing. So yeah.
Well, I guess in my mind I was talking more of a wrapper around, like, okay, so like Epic Games, for instance,
Right.
all these other games, they have lots of assets, or Unity engine, all these things. Like, they spent millions of man hours building up all these huge infrastructure projects that it's not going to be easy for these guys to just switch on a new blockchain on top of this thing.
A lot of them actually are easy to switch, because provided you can present as an API, all of them have APIs to, like, for some reason in the last 10 years, APIs is like the thing you have to have. Everyone's got them. So it's kind of, we're not there to take over. We're there to integrate, to connect. We're there to...
That's what I meant. So if you have an application that has an ingrained structure, because I dealt with a lot of ingrained structures, man. I know how hard it is for these people to adapt.
Yeah.
But if you have an ingrained infrastructure and you cannot bend to something new, like bringing in the MRP system or whatever, then you are going to need something that's be the light and affected, that would bolt on, that's not going to have any collisions with your existing stuff.
Primarily going to be used for that. But the way that we sort of bring rain to the fire is rain to the desert, I think is a better word, is that when you have these systems that don't flex, which, I mean, let's be honest, is like most of them, we have the ability to be a translator. So we can be like the...
Right, exactly. That's what I was saying. Like, if I can take this system and just bolt it onto something and start NFTing the shit out of my assets that are already existing, and then boom, everything in game is all of a sudden an asset. Totally. Holy shit.
Yeah. And so what I'd imagine us opening up is a sort of a store where people can write these integrations, and you can sort of go to the store and find, I'm running this version of this ERP system. Someone's already made an integration. Okay. And then you can pull it in or buy it or whatever. And it incentivizes people to improve it and to sort of make your integration better, because you want to then connect off to this other thing. So that's a major part of the ecosystem I see, is a store for integrations.
Right, because the problem I'm having now with the current system structures is that everybody's like building an NFT system and then putting a shitty game on top of it.
Yeah.
And I mean a really fucking shitty game. So it would be really nice to have a really nice game that's already existing, that everybody wants to play, and just put the damn NFT system on top of it.
Yeah.
Right? So that's
covered.
We
got you covered, and I think MSM would have a lot to say on that, because he's had a lot of experience with games. So, absolutely.
Well, we've had discussions about that too. So I mean, because this is stuff that I'm putting in specs, so as like sort of a use case for people who might be swimming around with investment cash or something like that. So
Well, I got to go in 15 minutes. Were there any other code questions you had, Ben?
Not yet.
No?
Not really. I think I got a lot of catch up to do right now, right?
Yeah.
There's definitely still like thousands and thousands of lines of code that I want to wrap my head around. What I'm like, I guess the only real question I have is like, what's the best place for me to focus while I'm reading? Obviously, the model system right now is the thing you keep kind of hinting.
Yeah.
Is there a way that I can do that that like helps me understand how all the pieces fit together? Like, is there an entry point in there that's like the most important thing to understand for the orchestration?
Yep. That file is called W18 source machines interpreter.js.
Machines. Right. So this is the thing that's actually running the blocks?
This is the hardest thing. This is the thing that, so there's two sides of code that comes before this file and code that comes after. All the code that comes before this file at runtime is tasked with selecting the next action to run in an isolated system. Isolation needs to be done. Sorry.
Isolation needs to be done.
No, it's fine though. It's fine. It's fine. It's fine. Like it's fine. Like probably.
You can do isolation in isolation, right? So
it's honestly it's fine. Plus, like Deno's got like fabulous isolation properties.
So are we running this on Deno? That's cool.
Well, no, but it will work there because it basically just uses ES6 imports. So
cool.
So it's designed with Deno in mind, in particular with the web worker interface that they supply, which allows you to lock down that web worker to do nothing, but do some computation. There's some extra API hooks that they need to add to the web worker model to allow you to set a RAM limit. So right now, like we would have to sample the RAM frequently and then kill the web worker if it started showing signs like it was trying to DOS out of the RAM limit. But they have in Deno, they have added hooks that do let you tie into the V8 isolate interface for controlling RAM growth. So they're probably at some point in the near future going to allow that control within the web worker. But yeah, so I'm not worried about isolation. It's going to be in web workers. They're going to be in Deno. They're going to be locked down. And for the point is like when you're running a blockchain that where you're trying to be the blockchain and everyone must come to you to drive your token price up, you kind of don't want people running your blockchain on their own. Whereas for this model, we actually want you to run the blockchain on your own, in your own installation, in which case, do we need to worry about isolation because you wrote the code? So it's almost like there's a use case where isolation actually adds an overhead that we don't need for the use case of running your own code in your own system. Yes, for mainnet, absolutely it needs isolation, but web workers is fine for that. Iframe's perfect, like all those things, not a problem. Sorry.
No, yeah, I'm just saying, yeah. I actually get it. I think it's sorry, go ahead.
The code that comes before interpreter.js is all about selecting the next action to run with what current state. The code after interpreter is how to deal with that action and what do you need to do next. And that includes draining the loopback channel, which is the nastiest piece in the whole thing. Like that was the hardest thing to deal with. It's like that conveyor belt that we were talking about, that sort of now you need to backdrive it sometimes with the loopback stuff so that it comes back down and all that. So I made the simple rule that every block loopback is always drained. It didn't make, like, why would you stop loopback halfway through?
Is loopback a lot like the way it was written the last time I wrote it? It's like it's a channel from the chain to itself. Like you just map the sends to receives and the receives to sends.
It's not quite that simple, but as a general, if you wrote that spec on a board, that would be enough to get going. It turns out it's quite a bit hairier than that.
Right. And do you still use it like to fulfill promises to yourself, basically?
You can, and this system also deals with weird cases like fulfilling a promise to yourself whilst you still have a pending promise to an outside system as well. And so it needs to deal with things like making sure loopback is still free to operate, even though overall you're in pending. Internally, loopback needs to clear because something might have happened that allows you to then resolve your external promise as well. Plus, sometimes you also need to buffer on the loopback. Like if you were pending externally and you did something that causes you to continue to be pending, then that loopback action now needs to be buffered and replayed for after you come out of pending. All those fun things. That's what happens on the other side of the interpreter.js file.
Right.
Files in here that are sparse, that don't really, haven't got to working on yet, transmit and receive. So right now, handling multiple connections to multiple validators is not in the system. That is the work I'll be taking on the week after next. So I've sort of jiggle them around. I'm always like aiming towards having these bits working, but those transmit and receive would be the most underdone files in the whole system.
Okay.
That's if there's one file. So how I made these machine files is that you can go to the Xstate visualizer and you can copy and paste that code in there and you can see it. Now, it is possible, because they're all actually nested within each other, you could make a small generator function that took all these machines and smack them together into one big machine, and then you could see the whole system as a single state machine. I would love to do that one day, but I have not done it because there's other stuff to do. But basically, when I picture the system, it is actually one big state machine. Each of these machine files represents a isolated piece of that state chart that can be thought about and reasoned about independently from the other pieces. That's it, I think. Producers should be straightforward. It's just any time that you need to make new models, producers is where I stored all the functions. I didn't want to put that functionality onto the model subsystem itself because it sort of clouds the purpose. The model system itself is for queries and for logic checking, importing, hashing, those types of low-level functions. Producing is more coordination type of a function, and so I've kept them separate. It seems to work. The machines are there just to basically coordinate and run the producers in the right order with the right inputs. That's literally all it is. And then in the services folder within the standard engine is just the pieces that you need to actually do something useful, like talk to the database or talk to the network. So they just give the machines that power.
I'm actually really glad. So, like, kind of reading between the lines, like, Interpreter is doing a lot of the stuff that Lyft was doing before, right?
Yes.
I don't know if you remember. That's years ago.
No. Lyft was a great name. It's just
No. I'm glad to see, because one of the things I felt the worst about handing that off was it was still just one giant function, and I'm glad that it's a machine now.
I had to break it down multiple times. Initially, I had one big machine as well, but Lyft balloons rapidly, and when you add a new feature, Lyft is the first thing to fall apart. So Interpreter equals Lyft.
Yeah. And I'm very, very glad you made it into a machine.
And you should feel bad about handing that off.
It's hard to get out of your own headspace, you know?
Yeah, I know. Yeah. Um,
Can you chuck the GitHub repository link into resources up here?
yeah. Hold on.
Up at the top in information, just check it in resources, just so we have a more permanent location for it.
So that is the project, and then the main repository is there. All the other repos that you see in there are basically things that I had to fork so that I could have a terminal in the browser, because people who make terminal packages don't consider browser users, which is a reasonable assumption.
No, it's not.
Yeah, because there is a Dreamcatcher AI repository on GitHub, so just it's not us.
That's the old us. This is the new
Oh.
us. They will become
Okay.
one later.
So we're gonna merge them.
Yeah, once Ben implements merging in the change for us, then yeah, we're gonna do that.
I got my work cut out for me if everything needs to be a freaking machine. I still never really spent enough time figuring out how to write stuff that way.
Look, it might not need to be a machine, but I can tell you what it can't be is a bunch of imperative function calls. So state charts have helped me get this far. I can't imagine, like, what I hope to happen is once we build the flow creator, then being able to design an internal business process will be the same as being able to analyze the running process of the actual blockchain itself, because they use the same language, the same inspection routines. And so you can sort of, like, you know, all the tooling we make to check the interaction between multiple chains, workflows that cross company boundaries, all that type of stuff, we can just apply that same tooling to analyzing our own core, which is great because I'd rather not make two sets of tooling, and I would rather have some tooling. So that's part of why I like state charts.
Yeah, I've done it a few times with my team. Like, I've asked them to make stuff on Lambda step functions or using machines in the code, and it's always easier to manage.
It's the key to composability, in my opinion, and it lets us talk more about, you know, a state chart is easier to talk about than a bunch of code that does who knows what with a bunch of, like, rammed in there functions that someone needed to just make it work for this demo. It's a lot better.
Anyway, I'm all good.
Cool.
Again, I'll try and get to the point where I understand what you're asking me to do with the things that you said are unfinished.
I'm actually not sure what I'm asking to do. I am very grateful for the opportunity even to explain what's going on to you. I find even that helpful. If you can find something that you're like, I think we should do this now, or I don't like how this bit was made, have you considered this or that? All those are great inputs.
Yep.
But if you want the model system different, you need to let me know soon.
No, I mean, it sounds all right to me. The only thing I worry about when you're doing weird translations like that is just what are the things you don't know that you're making a problem in the future.
Yeah.
But I can't see any off the top of my head, right? And we got, like, all the time we need to make it right if it is fucked up, right?
Not really, but yeah, I take your point. Okay, did you want to add anything, Troy?
I mean, the state change machine that you're referring to, can it just be just the substrate of the actual mainnet itself? That's the state machine?
No, we're talking about state charts. Let me pull up a link for you.
Oh.
So in under fuck. Oh, they've gone and made it a cool thing. They've called it stately. Well, that's stately.
Stately chart.
That's nice. Okay, so under resources, when we talk about state charts, this is the definition of them. There is a really good white paper on state charts. Let me try if I can pull that up. There was a guy. This is the probably the get started on state charts. There was a guy who wrote a white paper by Harrell in 1987. He worked for the Israeli military. State charts are great. I can't find the white paper offhand. Oh no, here we go. Got it. Can I drop PDFs into
Yeah, you should be able to.
Discord? This paper is great. So basically, what I'm saying here is that I made the entire system using state charts so that it's in the resources section, but the whole how the internals of the blockchain runs has been described entirely in state charts so that we can, first of all, easily reason about it at a high level. Second of all, when it comes to audit time, it will be simpler to explain. And my ultimate hope is that we can even get the core formally verified, because state charts are formally verifiable with like a massive asterisk dripping in blood on the end. But you've got more chance of formally verifying a state chart based program than you do something that you just went ahead and hacked together over several years with multiple people. So state charts all the way as far as I'm concerned. This is sort of the background resources on them.
Okay. Yep.
Sweet. I gotta run.
All right.
Thanks so much for your time, Ben and Troy. I hope that was useful for both of you. Was certainly useful for me.
Okay. Can we book the next one on a weekday?
You can book it anytime you like. What time would you like?
Like, I gotta get my calendar up. How about I'll ping you in the channel after?
Yeah, sure. Sounds great.
Okay.
Can you?
Well,
whatever time you pick, please make it not on the hour. On the half hour is best.
On that. Okay.
Yeah.
Why is that?
Long story. Not suitable for live stream.
Well, just end the live stream and tell us what's going on.
Yeah, could just do that. Hang on. Where's the goddamn off?